In this video, we will use 3D animation to show you how the wind turbine is working. A wind turbine is a device that converts wind's kinetic energy into the electrical energy. They are increasingly important source of renewable energy and are used in many countries to lower the energy cost and reduce the reliance on fossil fuels like coal, petroleum and gas. Wind turbine works on the simple principle. Instead of using electricity to make a wind like a fan, wind turbines uses the wind to make an electricity. The majority of wind turbines falls into the two categories, horizontal axis turbines and vertical axis turbines. The majority of the wind turbines consist of the three blades mounted to a tower made up from the tubular steel. Let's start with the base of the wind turbine. The tower is a crucial part of the wind turbine that supports all the other parts. It is not only supports the wind turbine but raises the turbine to a sufficient height so that the tips of the blades would be at the safe height during the rotation. Not only that, we have to maintain the height of the tower so that it can get sufficient strong wind. The height of the tower is ultimately depends on the power capacity of the wind turbines. The tower of the wind turbines in the commercial wind power plants usually ranges from 40 meters to 100 meters. These towers may be either tabular steel towers, lattice towers or the concrete tower. We use tabular steel towers for a large wind turbine. These are normally manufactured in the section of 30 to 40 meters in length. Each section has a flanges with the hole. A flange is a method that connecting pipes, valves, pumps and other equipments to form a piping system. Such sections are fitted together by nut bolts at the side to form a complete tower. The complete tower is a slightly conical in shape to provide better mechanical stability. On the top of the tower, there is a nacelle of the wind turbine. The nacelle is a big box that sits on the tower and houses of all the components in the wind turbine. It houses an electrical generator, gearbox, turbine controller, cables and a yaw drive. Let's come to the rotor blades of the wind turbine. Blades are the mechanical parts of the wind turbine. The blades converts wind's energy into the usable mechanical energy. When the wind strikes on the blades rotate and the rotation transfers its mechanical energy to the shaft. We design the blades like an airplane wings. The wind turbine blades can be 40 meters to 90 meters long. The blades should be mechanical strong enough to withstand the strong wind even during the storm. At the same time, the wind turbine blades should be made as light as possible to facilitate the smooth rotation of the blade. For that, we make the blade with the fiberglass and the carbon fiber layers on the synthetic reinforce. In a modern turbine, normally 3 identical blades are fitted to a central hub using nut bolts. Each identical blade is aligned at 120 degree to other. The process makes better distribution of mass and gives the system more smooth rotation. The blades have connected to the shaft of the wind turbine. The shaft is directly connected to the hub is low speed shaft. When the blade rotates, this shaft spins with the same RPM as a rotating hub. We couple this shaft directly to the electrical generator in the case of low speed generator. But in the most of the cases, the low speed main shaft is geared with the high speed shaft through a gearbox. The wind turbine doesn't rotate at the high speed, rather it rotates gently at low speed. But the most electrical generator requires the high speed rotation to generate the electricity at the desired voltage level. So there must be some speed manipulation arrangement to achieve the high speed of the generator shaft. That's where the gearbox comes into the picture. Gearbox increases the speed to a higher value. For example, if the gearbox ratio is 1:80 and if the RPM of a low speed main shaft is 15, the gearbox will increase the speed of the generator shaft to 1200 RPM. The gearbox is connected to the generator where the electricity is generated. The generator is an electrical device that converts mechanical energy received from the shaft to the electrical energy. Normally we use induction generators in modern wind turbines. Previously synchronous generators were popular for this purpose. The speed of the shaft can be made high by using gearbox assembly, but we cannot make the shaft speed constant. There may be fluctuation in the shaft speed because of the wind speed. So the speed of the rotor also varies, and this variation affects the frequency and the voltage of the generated electric power. To overcome these issues, we normally use induction generator for this purpose. If you want to know how the generator generates the electrical energy, let me know in the comment section. As we know, the direction and the speed of the wind turbine changes with the time. So to get maximum power of the wind turbines consist with other different systems. Now let's understand the working of turbine controller. A turbine controller is a computer that controls entire turbine. It starts and stops the turbine and runs self-diagnostic in the case of error in the turbine. On the top of the wind turbine, there is anemometer and wind vane that measures the wind speed and the direction of the wind and passes the speed and the direction information to the turbine controller. And then the turbine controller faces the blades in such a way that it cuts the maximum wind. According to the control signal from the turbine controller, pitch drive motors controls the angle of blade. Whenever the wind changes, it rotates the angle of blade to cut the maximum wind, which is called the pitching of the blade. Blades and other components in the wind turbine are in the nacelle. Whenever any changes in the wind direction, the nacelle has to face the direction of the wind to extract the maximum energy from the wind. For this purpose, yaw drive, a motor is used to rotate nacelle. It is controlled by a turbine controller that uses the wind vane information to sense the wind direction. Wind turbine requires the high speed of wind to generate the electrical energy. I hope you understand the working of wind turbines. To see how such things are worked, subscribe to my channel.